All right. Thank you all for being here. This is MongoDB chunks and more. You already know me. My name is Ivan. I'm a senior architect at Percona. And I work with MySQL and MongoDB technologies, as well as being certified in a couple of clouds. You know Percona already, so not going to bore you with this. Let's quickly talk about sharding in MongoDB. As you know, it's a method to distribute huge data sets across multiple servers. Or also, if you don't have a huge data set, but you have a high throughput requirement, you might need to shard. And it looks like this. There's a single big collection that you partition in smaller pieces, and each of those goes to a separate shard. And this is how it looks from an architectural perspective. You have a MongoS router that talks to config servers that have the information about where each piece of data is. And then you have the shards that have the actual data, and the router will talk to them. And if there needs to be any aggregation, for example, it will happen at the router level. So sharding is done at collection level, so you have to decide for each collection whether you want to shard it or not. You can have a mix of sharded and non-sharded collections. Always, you will access the data through the MongoDB router, whether it's sharded or not. Like I said, the config servers have the metadata, and each shard, in turn, is a replica set for high availability purposes. Okay? To shard a collection, we have to define the shard key, which obviously will affect the distribution of the documents across the shards. The shard key can be one or more fields of a document. We need to create an index before we shard, and then run the sh.shardCollection method so that MongoDB starts sharding this data. Okay. So this is an example of how it looks like when you do shard a collection. In this case, this is a collection called testcall2 inside the test database, and I'm sharding using the field v. And this is all the information that Mongo will say when you shard it. Okay. Basically, the important part is OK, 1. The rest just doesn't matter for this purpose. What's important about sharding is the concept of chunks. Okay. Basically, a chunk is a range of sharded data. And this is based on the interval of shard key values. So, for example, if you shard a collection that has an integer field, you might end up with a situation like this, where there are 4 chunks, where the first chunk stores any values between the minimum possible key and minus 75, let's say. And then the second chunk will store values between 75 and 25, and so on, until you get to the max key. One thing about this distribution to keep in mind of is that the lower boundary is included in the chunk range, but the higher boundary is not. Okay, so for example, this chunk that goes between minus 75 and 25 will include the value 75, but any data that has 25 will go into the next chunk, actually. And by default, the chunk size is 128 in MongoDB 6.0, but it's a value that you can change. Before MongoDB 5.0, any metadata about the chunks was stored in a collection called config.chunks, and you would have the namespace of the collection, and then the ranges that we just saw. Okay, so the minimum value and the maximum, and which shard this chunk lives in. Okay. Also, you'll get a field with the history, because chunks, as you know, move around the shards due to rebalancing. So you can easily see where this chunk was before, and so on. But now, starting MongoDB 5.0, there is a change in this structure. So the namespace field is no longer present. And now instead you have a UUID for a collection, as you can see here. So if you want to know exactly which collection is this chunk a part of, you'll have to do something extra, which is to match the UUID value with the contents of the config.collection collection. Probably this was done so that you don't expose the collection name and instead have a UUID that is like generic. For example, when you open a support case or something like that. So basically, if you want to find what is the UUID, you can do this query. Okay. So first you go to db.collections to get the name and the UUID, and then with this UUID you can query the chunks collection and get all of the chunks for a single collection. Let's talk about some of the background processes that work with chunks and ranges. First of all, we have the balancer, which is the background process that monitors collection distribution and will automatically migrate data across the shards to keep the cluster balanced. And usually this process is configured to run during a specific window, which normally is at night, so that it doesn't interfere with normal operations, as there is some overhead associated with the balancing process. There are a couple of things we can do with the balancer to modify its behavior. Specifically, there's two tunables. One is called secondary throttle, and basically this controls how each document moves. Basically, when the balancer copies a document over, by default, it doesn't wait for any confirmation, but you can change this so that at least, for example, 2 of the replica set members acknowledge this move before the OK is returned. So this effectively slows down balancing a little bit. So it might be helpful if you want to make the balancer do a bit less work, let's say. Similarly, wait for delete is another tunable. By default, it's false. And this basically delays the start of migrating another chunk until the current one is finished and all the migrated data is deleted from the source shard. So these are the 2 things we can play with in order to alter the balancer behavior and also its resource consumption. Another thing we can do is modify what the balancer tries to do with the jumbo chunks. However, the name of this parameter is a bit misleading. You can read about more about this in this documentation link, but really what this does is not to prevent migration of chunks that are marked as jumbo true, but instead prevents migrating chunks that are that have a large range. That's what the documentation says. So you might be wondering what exactly is a large range, and the answer is that it's calculated with this formula. A large range is considered when the number of documents in a chunk is larger than 2 times the max chunk size over the average document size of the collection. The problem with this estimation is that the document size might not be uniform. You might have collections where one document is small but other is huge. And I've seen clients that have distribution like this. So in this case, the estimation is really not reliable. The other background process that is important to balancing is the autoSplitter as well. And the idea with this process is that it tries to ensure that you don't get any chunks that exceed the maximum configure size. And how it works is that it will try to split any chunks that are bigger than the threshold whenever possible. Okay, and if there's no way to split them because the shard key cannot be partitioned further, for example, in the case where we were discussing before that we have an X shard key that is integer, if all of the documents in the chunk have the same value, for example, the integer 10, let's say, we cannot partition that further, so the chunk will be marked as jumbo. Some history about this process. In earlier versions of Mongo releases, this used to run in MongoS router. The problem with this is that you might have more than one router. Usually there are way more than one. So the estimations of when a chunk should be split were not reliable, because a single MongoS router doesn't see the whole picture of what is happening in the cluster, right? So this is why eventually it was decided to move the process to run instead on each of the shard primary instead of the MongoS router. But even after this change, jumbo chunks could still appear, okay? And a bit of a funny thing, it was actually removed, the autoSplitter was removed in 6.0, and I will show you a bit more about this in a second. So I wanted to discuss today some of the common problems that can happen in sharded clusters regarding chunks as well and balancing. The three more common issues, at least that I came across, is, for example, the first one is clusters that have too many big chunks that are not marked as jumbo, okay? For whatever reason, they grew and never were split. And the same can happen the other way around, right? If you delete a lot of data, perhaps you start now having too many chunks that are empty. Or maybe not empty, but have very little space usage.
And there's still flagged as jumbo instead of that point?
That is the third issue, actually. Chunks that were marked jumbo at some point in time, but now have actually lost weight because of deleted data or whatever. But once the balancer marks it as jumbo, it's no longer cleared automatically. So let's see each of these three problems in a bit more detail. Problem one, too many undetected big chunks. So some of the potential symptoms is that there are many failed migrations. If you check the logs of the balancing, you will see many messages about failed migrations. Also migrations that take a long time and could cause stalls for your operations in the cluster. So if during the balancing window you notice that your application response time is increased, it could be because of this problem. So the solution for this is to read through all of the chunks sequentially and calculate what is the real size that they have. And if we find any chunks that have exceeded this configure max size, we go and split them, okay? So basically, in a more detailed matter, this would mean iterating through the config.chunks collection that we saw at the beginning that has all the information about the chunks, and run the data size command for each of the ranges. This command will calculate the real size or the estimated size, depending on the parameters that you use, but will give you the range size.
All right, that first one, they can deduct chunks. Is that the...
Right. That is inside the config server replica set. Right. This will go to each of the shards and calculate the real size by looking at depending on the parameter that you use, it will do an estimation based on the average document size, or it will actually go read all the documents and calculate the real size.
I think it was David that was saying that sometimes, if I understood this right, you have to be saying sometimes the metadata is incorrect, or that he was saying that it's incorrect sometimes. Incorrect, it's flagged.
Yeah, I think he was referring to when there is orphan documents. Yeah, that's forget about that for now. So basically, after we calculate the data size, we can decide whether we split it by using the split find function. Okay, And I have a script for this in the Percona blog. If you're interested, you can read a bit more about the solution to this problem, okay? Problem number 2 is too many empty or small chunks. This is common when documents are short-lived, for example. And the symptoms could be that you have shard imbalance. Also, when you have more than 1 million chunks, the metadata operations become slow due to how many entries there are in the chunks collection. So it might happen that a move chunk that happens in the balancing window takes more than 1 second. And every time this happens, you notice that your application gets stalled and the response time increases. The solution for this, the first part is similar to the previous problem. We have to scan through all of the chunks again sequentially and check the sizes. But in this case, instead of splitting, we want to do the opposite, right? We want to convert or merge the chunks together so that while they are under the max configure size, we have as little chunks as possible, let's say.
I think you're only going to merge with the combining sides. It's still, yeah.
Right. Yes, we have to take that into account. So basically, again, steps 1 and 2 are the same. And for step 3, to merge the chunks, we have to keep in mind that if the chunks are on different shards, they will have to be moved together before we can merge them. So our script needs to detect this condition and do the move chunk first. However, one thing to keep in mind about this is that when you move a chunk, it might trigger a metadata refresh, which also might cause a stall. So it's complicated. There is a bit more info about this in my other article in Percona blog, as well as the complete script. If you're interested, you can check there. Finally, problem number 3, chunks that got marked jumbo at some point in time, but then lost weight because of deletes. In this case, it can also cause shard imbalance because chunks marked as jumbo are not moved. Okay, the balancer ignores them, basically. And the other thing is the balancer, again, doesn't clear the jumbo flag once it's applied. So that means we have to do it. So the idea would be to query, but in this case, we don't have to go through all of the chunks. Just we can query for the ones that have the jumbo true property. We can check their size again with the data size command and try to split them if possible. If we were successful, then we just go ahead and clear the jumbo flag. Basically, the query will look like this. Okay, so we query the chunks collection. And in this case, we have the condition of jumbo true, so that just returns the jumbo chunks. To check their size is data size command, same as before. And then we can run sh.splitFind to try and split them, if possible. Finally, we run the command to clear the jumbo flag. This is also there is also a script for this in my 3rd article. So if you're interested, again, you can refer to the Percona blog. Blah, blah, blah. So after everything we saw, we can start to think about an algorithm or a few steps we can follow in order to defragment a collection. The idea would be to go through all of the collection's chunks, and then if we notice that there are small chunks we can combine, we do that first, and then afterwards we look at any chunks that are large and need to be split. So first we combine as much together as possible to reduce the overall number of chunks, and then we go through any that exceed the maximum size and split them or try to split them.
And you're trying to merge the small ones first to reduce the size of the metadata?
Yes. The thing is, when you move it from one shard to the other for combining, as I said, it might trigger a stall. So we
easy way, I guess. A split would probably also trigger.
No, the split, I don't think so. I mean, I haven't seen it at least. The move chunk, yes. So the idea would be first to reduce as much as possible, and then once we've done that, we can split any that were outliers. But it makes sense to do it in this order specifically. The things to keep in mind about this whole defragmentation problem, obviously the chunk analysis can be slow, especially if we cannot rely on the average document size for calculating estimations. If we run data size with estimate true, again, it might not produce a good value. So we might actually need to run it with estimate false to get the real size of each chunk. The good thing is that we can run this analysis on the secondary members to avoid impacting our primary, because the size of the data will be the same. So we can run this with a secondary preferred read preference. The other thing is that after we are done moving and combining and splitting, we might end up with an imbalanced cluster, which means that it might take some time to do a rebalancing, and we might need to run the balancer probably outside of our normal window, maybe, just to recover from that. And the other thing to keep in mind when you run a mob chunk command is that if this chunk is actively being written to, it might actually fail to move. There is a write queue for the specific chunk that has 500 megs in size. So if you write more than that while the chunk is being migrated, the migration will be interrupted. Yeah. There's no way to tune this at the moment. Some of the changes that appear in the newest releases of MongoDB. As I said before, the autoSplitter is no longer running, okay? The only case where chunks may be split is if the balancer decides to move them to another shard. In that case, there might be a split happening, but there's no longer the old autoSplitter process. And the chunks are now referred to as a range instead. So now ranges can be of any size. The idea is that the balancer is now trying to balance according to data size on each of the shards rather than the number of chunks, which was the old behavior, okay? So basically the ranges do not honor the chunk max size anymore, which might be surprising after all the work that had been going on in the previous releases. Time will tell if this will solve the problems for good or no. Most of the people nowadays are still upgrading from earlier versions, so they carry over the problems. So when we have clusters that are deployed in Mongo 6 and maybe a year from now or so on, we will start to see the effects of these changes for real, right? There is also a new command now in Mongo 6 to defragment a collection. So this basically does more or less the steps that we discussed, although there is not much we can tune about it. We have to rely on what's available. But at least we have something, so it's good. And the way to run it is to do admin command, and then the command is called configure collection balancing, and you give it the database and collection, and that's all you have to do.
So then deep right is to merge all those flat chunks.
Yep.
Yes. It's not going to split bibbles, right?
Yeah, it does everything, really. It does a bit of everything, yeah. After all that we said, you might be wondering, when should we consider defragmenting a collection? Just to give you some general guidelines, when you have collections that exceed 10,000 chunks, it's a good idea to start doing some analysis and seeing if it might be worth to do it or not. You have the scripts to check this in the blog articles, so you can run them just to get a report without making any changes. If you notice stalls during the balancing window, also it might be an indication that you need to look at this. And if you have collections that were created in earlier versions of MongoDB, especially when the autoSplitter was running in the MongoS router, it's very likely that you have jumbo chunks that are undetected. As usual, with new commands, be careful with bugs. MongoDB released this statement in the documentation. So this new defragment command is not recommended to be used until MongoDB 6.0.4. And obviously don't use it on any of the non-GA releases like the 6.1 branch. So here it says that it can make databases or collections unavailable for extended periods of time. So be careful. And how long does this take? Just to give you some estimates, if you have a collection with 10,000 chunks and you're running the analysis with the estimate false, so to get the real size of the data, it might take around 3 hours to get the data. For a collection of 100,000 chunks, roughly 1 day, and for 1 million chunks, around a week. Is running what? No, I mean, the good thing is you can run this estimation on the secondary nodes, so as not to affect your primary. So you can leave it running and just, yeah. Actually, the scripts that I have in the blog print the progress from time to time and give it the speed, so you can know what's going on, really. And we run it on customers several times, so it's good. Okay. So conclusions. Collection fragmentation is a problem, especially on earlier MongoDB releases. The changes that happened in the autoSplitter were in the right direction, but still collections are fragmenting over time, even in 6.0. So the takeaways before MongoDB 6, if you're still not in the latest version, check chunk distribution often. And you can rely on these scripts or develop your own scripts to check the chunk sizes and do the combinations and all of that. And it's recommended to upgrade to 4.4 at least, which is the version that has these changes to the autoSplitter, which make life easier, as well as some other improvements. Right.
Although it's at 11 February.
Yeah. Yeah, that too. And if you are already in Mongo 6, you can rely on this built-in defragmentation tool if you want. Although I still like to have my own scripts because you have more control of what happens. You can throttle if you want, sleep every now and then, and so on. Remember to only run this command if you're in 6.0.4 or newer. And check the distribution often, because even if you fix it, maybe 6 months from now, the problem can manifest itself again.
So it's sorted along bag that the balancer might trigger.
No, the fragmentation is not automatic. I mean, there were changes to the balancing algorithm, but if you want to defragment collection, you need to do it explicitly. You need to call this new method.
Referencing easier or that chunks.
Right. This is actually the chunk fragmentation. The disk fragmentation is different issue. We have to do an initial sync to fix that. Yeah. So this is all about the metadata, really, and reducing the number of chunks to avoid stalls during balancing, basically. That's the takeaway. Any questions, comments? Thank you very much for coming.
Hey,